We're going to graph the parent function and then A, B, C, and D. Let's start by coming up with values that are reflective of this function. So I'm going to first rewrite this. I'd like you guys to do the same. We're going to write log 3/2 x. Now, this is equivalent to y. I could write equals y on the left, or I could write equals y on the right. This is in logarithmic form. Let's write it in exponential form. I take whatever the base is, I raise it to the value on the opposite side of the equal sign, and I set it equal to whatever value is directly behind the base. That's going to allow me to correctly graph this function. So let's start by putting in 0 for y. Any value raised to the 0 is equal to 1. Let's go ahead and plug in 1. Any value raised to the first power is itself, so 3/2 or 1.5. Let's plug in 2. 3/2 squared would be 3 squared over 2 squared. 3 squared is 9. 2 squared is 4. So I could write 9 over 4, but on a personal level, that doesn't help me to graph it. I like to think of it as a decimal. So I'm going to come up here and I'm going to go 9 over 4. We can see that's 2.25. Okay, let's allow these 3 points to help us to graph the function, and it'll help us then as we translate it. So over here, I'm going to go to 1, 0, 1.51, and 2.25 and 2. And I would like you to take out that highlighter, and with our log functions, we're going to have a vertical asymptote. As it moves to the left, it's going to get closer and closer to that vertical asymptote. It will never cross it. All right, we do have an x-intercept here. Notice it's x-intercept. There is no y-intercept for this function. We have an x-intercept of 1, 0. And I should put in these particular values, 1, 0, 1.51, and 2.25. And you could have an equivalent fraction form. Okay, so there's a couple things to consider when we're looking at A. We're going to refer back to the parent function. Notice how it has the exact same base. So there's 3 things to consider. I'm going to write this down. If this is new to you and you feel like you're struggling, we're going to talk about that. So how do we go about doing this? The very first thing we need to do is we need to adjust for some shifts. We are going to shift this opposite of what you think. It's a horizontal shift. We're going to go opposite. So we're going to take this, instead of going to the left one, we're going to go right 1. And a vertical shift up 2. So right 1 and up 2. So this vertical asymptote has now been pushed to the right 1. And all my values are going to be moved up to 2. Please draw a little arrow here out front. A little arrow here to this negative sign out front. This negative sign out front is going to affect the output or the y values. It's going to affect the output or the y value. So I'm going to take each of these values times a negative sign. So now let's shift this. So I'm so sorry, people are coming in here and it's distracting from my concentration. We've shifted here to the right one. We're going to shift everything up 2. So I'm going to come up here and I'm going to think of this intersection between my highlighted lines as this is the origin. So sometimes students like to put a little X. That's like my new origin. I've accounted for the horizontal shift and I've accounted for the vertical shift. The only thing I need to do with these points is if there's ever a negative sign out front, or actually any value other than 1, we need to multiply that times the y's. So think of this as 0, 0. I would go to the right 1 and then, well, when I take negative times 0, I still get 0. So I'm going to go right 1 and that's a point on this function. Then I'm going to go from this position, my new origin, I'm going to go to the right 1.5, but instead of going up 1, I'm going to go down 1 because this value is being multiplied by the y. So I'm going to go from here 1.5 to the right. Instead of going up 1, I'm going to go down 1. I'm going to go back to this position. I'm going to go 2.25 to the right. Instead of going up 2, I'm going to go down 2. 2.25 to the right. Instead of going up 2, I'm going to go down 2. 1 and 2. And we can see this is my new function. If we had to describe, whether in written communication or verbal, what happened, we shifted everything to the right one, we shifted things up two, and normally we would say reflect across, we'd say reflect across the x-axis. In this case, we're reflecting across the line y equals 2 because of the vertical shift. Last thing, my apologies once again, we have people coming in late. The last thing I do want to do is we need to identify what the x-intercept is. So I know this distance is 2.25. I just went to the right 2.25 for my new origin, and I dropped down 2. Why did I drop down? Because of the negative sign. So I know this is from this position, it's 2.25 to the right. But notice, I want to find the exact. I don't want to provide, unless if it's a decimal, it needs to be a terminating decimal, nothing rounded. What is this exact point? Well, this is a distance of 2.25, but we need to add 1 on because we shifted it to the right one. So grab your calculator. We're going to go 2.25 plus 1. I would be comfortable if you write 3.25, comma 0, or as a fraction, I want you to recognize it could also be represented as 13 over 4. So whether we write 13 over 40 or 3.25, they are equivalent positions. We're going to drop down and we're going to try a few more like this just to build your confidence, and then we'll come back up to B and C, which are similar. If you're watching this video, please go ahead and write down this example. We're going to have negative log base 3/2 of x plus 2 plus 3. I'm going to press pause, and for this one, this is just additional practice because I know students struggle with this, and we're going through information so quickly. I'm going to go and shift this to the left 2, and I'm going to shift it up 3. So left 2 and up 3. I know with my little homemade graph, it may not be as nice. Now, I say to students who are doing this initially learning it, I say afterwards make a little check mark so you know that you can identify what you've done and what you still need to do. I still need to take care of this negative sign. Any negative sign that is out front needs to be multiplied by the y values. So it'd make it 0, -1, and -2. This is like my new origin. So to correctly graph this function, I'm going to go to the right one, and then I would take this times a negative, but that doesn't change the value of 0. So from here, I'm going to go right 1. I'm going to go back to my new origin. I'm going to go to the right 1.5. Instead of going up 1, when I multiply it by a negative, I'm going to go down 1. So right 1.5 and down 1. Then I'm going to go right 2.25, and instead of going up 1, we're going to go down 2. Right 2.25 and down 2. So there's right 2, 2.5 is about right there, and down 2, and we can see the basic shape here. As it moves to the left, it gets closer and closer to that asymptote of x equals 2, and it continues to go in this direction. Additional practice, I'm going to go down below where we see additional graphs, and this is the function I'm going to graph. So I'm going to move to the right 3, I'm going to move down 4 as I identify the shift from the parent function. So down 3 and to the right 4. All right. Now when I think of these original points that I created from the parent function, I need to keep in mind that there's a negative out front. If that occurs in front of the log, we're going to multiply each one of these values times a negative. So these are my original values so that everybody can see it. That's watching the video 1, 1.5, and 2.25, 0, 1, 2. I'm going to take each of these values times a negative sign. This is my new origin. I'm going to go right 1, and taking a negative times 0 does not impact anything. I'm going to go to the right 1.5. Instead of going up 1, I'm going to go down 1, 1.5, down 1, right 2.25, right about here, and down 2 instead of going up 2. You can see it's looking something like this. If we look at B and C, we're now adding a new twist to this. Whenever there is a negative sign inside the parentheses here that would describe a horizontal shift, when there's a negative sign there, we have to rewrite it. and we have to pull out the negative sign. So please help me in rewriting this. We have log of 3/2. That shouldn't have been that much space, sorry. We're going to pull out a negative sign. And now we need to put what should go inside of here to represent negative x minus 2 when we distribute. It'd be x plus 2. Let's make sure I didn't make a mistake. Negative x subtract 2. This will describe the horizontal shift. So I'm going to go left 2, just opposite of what you think, and I'm going to shift down 2. Or down 1. Let's first do that. So on our graph, taking that highlighter, let's go to the left 2, and let's go down 1. And once again, I always suggest to kids, once you take care of that, you do something like you check it off, just to make sure that we have accounted for all of the transformations in this graph. Okay, please circle that negative sign that I factored out inside the parentheses. If we have a negative inside of the parentheses that describes the horizontal shift, instead of it impacting the outputs or the y values, it impacts the x values. So I'm going to write down our values that we have for x, y, and z here. So or x, y, and z, we don't have a 3D graph for x and y. So 1, 0, 1.51, 2.25, and 2. Now this negative sign is going to impact the x's. Remember, this is like my new origin. So from here, I'm going to go not to the right 1 and stay at 0. I'm going to go left 1 and 0. So from here, left 1 and here's 0. Then I'm going to go 1.5 to the left and up 1. 1.5 to the left and up 1. 2.25 to the left and up 2. 2.25 to the left and up 2. And we can see this basic shape here. When there is a negative sign, we'd say it translates across the y-axis. So if I simply put a negative sign in front of this x and I asked us to graph it, this is what it would look like. It would reflect across the y-axis. And it's done that. We did reflect across the y, but then we also shifted it to the right too. This would be my function. Now let's go ahead and let's identify what this x-intercept is. So here'd be the x-intercept. We know this distance, if I come back here, this distance is 1.5, but we already shifted it to the left too. So we went 2 to the left, and then additional 1.5 would give us negative 3.5 and 0. Negative 3.5 and 0. Now we could also represent that as a fraction. I want you to be comfortable with that either one of these answers would be fine with me. Let's rewrite part C. So I'm going to rewrite part C. I have a negative sign out front. And the only time I'm thinking about rewriting this is whenever I see a negative inside of the parentheses behind the log base. So I'm going to factor out the negative sign and I get x minus 1. And it's easy to make small mistakes here, so I want to go back and make sure. Negative x, perfect. Positive 1, great. So this says I'm going to shift this to the right 1, and I'm going to shift this down 2. That's the first thing I'm going to do. I'm going to go to the right 1 and down 2. Horizontal shift to the right 1, vertical shift down 2. This is my new origin. I'm going to put a little X there to represent that new origin. And again, as I've shared with you before, I think it is beneficial to go through and then just to mark off what we've taken care of. Whenever we have a negative sign out front, I'm going to go ahead and rewrite these parent functions, 1, 0, 1.51, 2.25, and 2. Whenever we have a negative sign out front, this impacts the outputs or the y's. So if I could draw an arrow, it would come right up here. So I'm going to take each one of these times a negative. Well, that ends up with 0, negative 1, and negative 2. And whenever we have a negative inside, it impacts the x's. Times negative 1, times negative 1, times negative 1. So here's my new origin. After I translate it, I'm going to go left 1, and then I'm at 0. Left 1, and at 0. Left 1.5 and down 1. Left 1.5 and down 1. Left 2.25 and down 2. 1, 2, and down 2. 1, 2. right? And this is our translated function. Question right now. I have a student here with me and she's like, why are they open circles? Mathematically, they shouldn't be. That would mean there was holes in the graph. I just want to differentiate between how I identified our new origin. That's the only reason why. But technically, when you graph these, no, they should not be open circles. I was just trying to differentiate so there's no confusion.